All right, we're going to do some more naming here. We're going to do it this time. We've got some cyclic compounds, and so we're going to have to use the rules for cycloalkanes in order to get this together. And so let's take a look at what we got. So the first one is a three-membered ring. So 1, 2, 3. So it's cyclopropane. And remember, when we number a ring, the first place that there's a substituent, that's going to be the first position. So this is 1-methyl cyclopropane. Okay, moving on to the next one. What do we got here? We've got a 6-membered ring. 1, 2, 3, 4, 5, 6. So it's a 6-membered ring. That's a cyclohexane. And it looks like we've got three substituents. And so we want to number the molecule in the way that gets us the lowest amount of substituents. So I could do this 1, 2, 3, 4, 5, in which case I would have a 1, 2, 5 set of substituents, or I could go 1, 2, 3, 4, 5, 6 this way, in which case I would have a set of 1, 2, 4. There is one more possibility. I think there's actually two more possibilities. So let's go ahead and let's back up some of those and let's redo it. I can go 1, 2, 3, 4, 5, in which case that would be 1, 4, 5. And then finally, I think I could also do 1, 2, 3, 4, 5, 6. I think that was going to end up being 1, 3, 4. And so I do have 4 different sets of values. And so we got to pick the right one. Is it 1, 2, 5, 1, 2, 4, 1, 4, 5, and 1, 3, 4? I think it's going to be 1, 2, 4 because that gets us the lowest possible sets of substituents. And so if I remember correctly, go back to that where I had the blue numbering. There we go. There's the blue numbering. That's 1, 2, 3, 4, 5 counterclockwise, starting with the ethyl group. So 1, 2, 3, 4, 5, 6. So now I've got it all sorted out. What do I have at each of these positions? It looks like I have an ethyl group here and an ethyl group there, and then I have a methyl group there. So let's put it all together. It looks like it's going to be 1, 4 diethyl 2 methyl cyclohexane. Make a little room. Make a little room, cyclohexane. There we go. All right, let's move on to this next one. This one's straightforward. It's a 4-membered ring, 1, 2, 3, 4. I've got an ethyl group here and an ethyl group here. It turns out they're the same group, so it doesn't matter which way I number it. 1, 2, 3, 1, 2, 3. I could number it counterclockwise or clockwise. I get 1, 3 diethyl. So it's 1, 3 diethyl cyclo, and 4-membered ring would be butane. Okay, that one's straightforward. Let's take a look at this one. It's a 5-membered ring, 1, 2, 3, 4, 5. And how do I number it? I can number, it's going to be obviously 1, 2, 3. But the question is it 1, 2, 3 that way, or is it 1, 2, 3 this way? It's a tie either way. So I need to pick the way that starts alphabetically. And so that means that I need to go ahead and name the substituents in order to sort that out. Well, what's this substituent over here? That's going to be a methyl group. And what about this substituent over here? What is it? This is I have a methyl group off of a two-membered ring, or two carbon chain with a methyl group off of it. So this is a 1-methyl ethyl group. And so that means 1-methyl ethyl comes after methyl. And so the red numbering scheme is the correct numbering scheme. So putting it all together, I have 1-methyl oh, sorry. What I forgot was that they've still got this group here, ethyl. And this is what I was initially getting confused about, is that I used alphabetizing the two methyl groups, so the methyl and the methyl ethyl, to decide which way to number it. But when I write the name, I still consider all of the groups to write the name. So it's 2-ethyl, 1-methyl, 3 1-methyl ethyl cyclo. And let me see if I got a little bit more room to move it around just one more time. Cyclopentane. Okay, that's a big name. 2-ethyl, 1-methyl, 3 1-methyl ethyl cyclopentane. Okay, all right, here we are. The big circle. One last naming to really test all of your rules. If you can do this, then you've gotten all of the rules down. And I designed this one specifically to test you on every single possible rule that I could think of. All right, well, let's count the ring first. Let's make sure there's no doubt on how many carbons there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a cyclo-nonane. Okay, so there's lots of different possible ways to start the numbering. What I would like to do is eliminate any possible way that sort of starts in the middle, because that would be 1, 2, 3, 4, 5, 6. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's definitely going to be a larger set. The smallest set is going to be one of the ones that starts here, 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 or here. And so let's think about those. So I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, in which case that set would be 1, 2, 4, 5, 6, 7, 8. That would be my set of substituents. So again, 1, 2, 4, 5, 6, 7, 8. If I start with this one and go 1, 2, 3, 4, 5, 6, 7, 8, 9, I get the same set of substituents. 1, 2, 4, 5, 6, 7, 8. Okay, let's compare a different direction. So I'm going to erase, so I got some room here to deal with things. So let's try 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1, 2, 3, 4, 5, 7, 8. And then if I go another direction over here, I would get 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 7, 8. So remember, there were other ways, and that would have been to start in one of the positions in the middle, in between substituents, but we know that that's going to get us a higher set. So we started at the positions only at the end, because we know one of those positions is the lowest set. Well, these are the same, so we have to pick between that one, and these are also the same, and so really we're only picking between A and B. And so let's take a look at the set A and the set B. Set A goes 1, 2, then 4, 5, 6, 7, 8. Set B goes 1, 2, 3, 4, 5, and then 7 and 8. Well, the 7 and the 8 are common with all four sets. And so it's really the other values that help me determine which is the lowest possible set. And so take a look. In the top set, I go 1, 2, 4, 5, 6. And in the bottom set, I go 1, 2, 3, 4, 5. So it is set B that is the lowest set of possible numbering. And so that was the ones that started with either the chlorine group or the bromine group. And so that means I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, or I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've narrowed it down. We took probably 5 or 6, 7 different ways to possibly number it. We narrowed it down to 4, and of the 4, we've narrowed it down to 2. And now we need to pick which 2 of those. Remember, both of the possible versions of B have the same sets of numbers for the different substituents. And so now we have to pick the substituent that comes first alphabetically. So is it bromo or chloro? Well, bromo comes first alphabetically. So what that means is that the actual way to number the ring is the red set. And now we've numbered the ring. Now we have to name everything. Here's the hard part, right? We're going to name everything. Okay, so let's see if I can get a little bit of room here. Just want to move this up just a little bit. All right, so what do we got here? This is an ethyl group. This is an ethyl group. This is an ethyl group. And this is an ethyl group. So we have tetraethyl. And where do we have it at? We have it at 2, 4, 7, and 8. Okay, so that's one set that we're going to need to deal with. We also said we had a chloro group. So that's a 5 chloro. And we also have a 1 bromo. And so the only other one to figure out is this one. And so it's a 1, 2 carbon chain with a chlorine group off of it. So it's a 1 chloroethyl. And where is it located? It's located at the 3 position. And so we have everything sorted out. Now we just need to alphabetize them all. And doing alphabetizing, we start with E versus C versus B versus C. And so which C comes first? Is it chloro or chloroethyl? Chloro comes before chloroethyl. So it's 1, 2, 3, 4 in order. And so let's put it all together. Let's see if I can actually get some room down here. Okay, so let's say a little bit more room actually. Okay, so well, let's do it. So I have 1, putting it all together, 1 bromo, 5 chloro, 3, 1 chloroethyl, 2, 4, 7, 8 tetraethyl, and it's a cyclo non-ane. We did it. Boy, that's a long name, but really, look, if you were able to examine this ring structure, this particular ring structure, you were able to get everything sorted out. So you really have mastered naming at this point. At this level of chemistry, you've mastered all the skills you need for the very first part of naming. Okay,